For the last lesson in week 16, we're going to talk about solving a system of equations using algebra. So the previous lesson we did it with graphing, and I'm just going to go back to that last question. So the last question on the last video, we found out without a graphing calculator of what our answers would be. But let's look at what that looks like with a graphing calculator. Okay, so these two equations, y equals x squared minus 2x minus 8, and y equals 5 halves x minus 3. Here's what it looks like. And so we can see we had one of our answers correct, because we estimated that we got 2, negative 8. And then the other one, we said negative 2, 2, but actually it's negative 2.5 and 3.25. So I'm going to write those answers on this piece of paper that we had negative 2.5, and 3.25, and then negative 2, positive 2, negative 8. So let's go back to the screen. And I just wrote those down. There's an extra little line there. But these were our 2 points that we had on the previous problem, because we're going to do this same problem algebraically. So we did it on a graph, and we saw on the graph where they were, but our notes, remember, we just estimated. So we weren't exactly accurate. We were off on this point. We got this one right, but we were off on this one. So what methods have we used to solve? We like set the equations equal to each other. We've also done substitution and some other things. Why is this blurry? Let's try to get it. So we're going to use one of the methods. We're going to set them equal to each other. We're going to solve. The only difference between this and the previous solving systems is we didn't have a quadratic or something with a squared. We just had two lines that we set equal to each other. So this one, we're going to have y equals x squared minus 2x minus 8, and y equals negative 5 halves x minus 3. We see how they both equal y. So y could be represented by x squared minus 2x minus 8, and then y can also be represented by y equals negative 5 halves x minus 3. So we're going to set those two items equal to each other, since they're both equal to y. One of the first things we notice is there's a fraction. So to get rid of that, let's multiply both sides by 2. And by doing that, what we're going to do is eliminate the fraction. It's called fraction busting. You see the word right there, fraction busting? I'm going to distribute the 2 here. We get 2x squared. 2 times negative 2 is 4x. 2 times negative 8 is negative 16. Now, why it's so important to fraction bust is right here. This 2 is going to cancel out that 2, and we're going to end up with negative 5x minus 2 times 3 is 6. So remember, we're distributing it to every term inside. Now we're going to set stuff equal to 0. So we set equal to each other, and then set equal to 0 is the other thing we're going to do. So I'm going to add 6 to this side, so that cancels. If I add 6 here, I'm going to add 6 here. These are like terms because they're just plain numbers. I'm going to go ahead and do 2 steps in one. I'm going to add 5x here so that I get 0 on this side, but if I add 5x, I'm going to add 5x over here. Notice I lined it up with the like terms. So we get that this side equals 0. Those terms cancel out. Over here we get 2x squared. A negative 4 and a positive 5 is 1x. And a negative 16 plus 6 is a negative 10. So now that we've set it equal to 0, we're going to factor this. And the easiest way for us to factor is to organize our stuff in the little perfect square. So the first number here, 2x squared, goes in the top left, then negative 10 here at the bottom. I'm going to multiply those two together, and we get negative 20x squared, and then this middle term goes on the bottom. That's a 1x. So what numbers can you think of that multiply to 20, negative 20, and we can get a 1 out of? How about 5x and 4x? 5 times 4 is 20. One of them needs to be negative, but I want it to be a positive 1. So I'm going to make this a negative 4. And I'm going to put my -4 somewhere here. -4x and 5x. All right? So I know that I'm going to set this up. I'm going to have this x and x. One of them has to be x. X times x is only x squared. I need a 2. So if I'm going to think about where I put the 2. If I put the 2 here, 2 times what makes 5, that's not an easy number to come up with. But over here, 2 times what makes -4, that's a -2. And then -2 times what makes -10, how about a 5? And now here's my factored terms right here. 2x plus 5 and x minus 2. And I'm going to set each of those, we're going to do the zero product property, equal to 0. I'll come over here where there's some space. I'm going to go 2x plus 5 equals 0. Subtract 5. We're going to get 2x equals -5, divide by 2. And I get x equals -5 halves. -5 halves, which is the same as x equals -2.5. Right? There's one answer. And then my next one, this one is x equals 2, so I get x equals 2. So there's my x values, -2.5 and 2. Now, how do I find out what those points are? I'm going to take this 2 and this -2.5, and I'm going to plug it into either this equation or this equation. Well, that one has a fraction, so I really don't want to use that. So I'm going to go y equals -2.5 squared minus 2 times 2.5 minus 8, and y equals 2 squared minus 2 times 2 minus 8. And here, this one, I get 4 minus 4 is 0, minus 8, -8, so there's -2, -8. That one, and why is that so important? Because remember where we started, we knew from the graph that they were those two equations crossed at the point 2, -8. Oops. I'm sorry, that was a +2. +2, I plugged in a +2, so +2, -8. And then here, 2.5 times 25 times 25, that's going to be 6.25 minus 5 minus 8. And what is that? That's going to be probably 3.25. Let me make sure I'm right. I need a calculator. Plug that into the calculator. Do I have that right? Oh, minus -2.5. So that makes it a +5 right there. This is supposed to be a negative. There you go. 6.25 plus 5 is 11. 11 minus 8 is 3, and then the 0.25. All right? And so that was -2.5 comma 3.25. So these are our answers. And remember, they matched with what we got when we graphed it. So that's kind of nice. Let's look at this next problem. And we're going to do the same thing. We're going to use algebra to solve this equation. We're going to set the two equal to each other. And then we're going to check it when we're done on our Desmos graph to see if our answer is correct. So I have y is equal to x squared minus x minus 2, and y is equal to x squared plus 2x plus 1. So what we're going to do is we're going to set those equal to each other. X squared minus x minus 2 equals x squared plus 2x plus 1. One nice thing is if I subtract x squared from both sides, okay, those cancel. So let me go ahead and add x to this side. And let me just see what's happening here. -2 equals 3x plus 1. Here's the term with my x, all on one side. So let's get the numbers on the other side. So we get 3x equals -3. Divide both sides by 3. You get x equals -1. Oh, there's only one answer. That's kind of nice. Now I'm going to take this -1. I can plug it into either equation. It does not matter which equation you plug it into. What I noticed, though, is this one has a lot of negatives in it. Negatives tend to mess people up, and people make mistakes. So I'm going to take the -1, I'm going to plug it over here, and I'm going to get -1 squared plus 2 times -1 plus 1. I'm going to get 1 minus 2 plus 1. 1 minus 2 is -1 plus 1, and that equals 0. So my point is negative 1, 0. My x value is negative 1, and when I plug negative 1 into the equation, solving for y, my y value is 0. So what this answer is saying is that if I were to graph these two equations, the graph will show that those two graphs will cross at the point negative 1, 0. So we're going to go to our graph and look at that. Let me switch over here to my graph. I'm going to take off these two equations that we don't want anymore. And here's the first one, x squared minus x minus 2. It's that green graph right here. And here's the second one, x squared plus 2x plus 1. When I turn that one on, okay, here's the two graphs, and look at the point. They cross right here at negative 1, 0. And that's what we got doing it algebraically. That's nice, you know, that we get the graph actually matches the work that we did. That's super nice. All right, your homework is going to be page 6. There are 3 problems on page 6. There's 3 problems on page 6. These first 2 right here, okay, go by substitution. Basically, you're just going to set these two equations equal to each other. X squared equals 2x minus 1. So then don't forget to set equal to 0. You're going to move everything to one side. You'll have to factor it. Here you're going to set these two equal to each other and solve for it. And then when you're done and you get an answer, go back to Desmos, graph those two and see where they are. But we want to see that your algebraic work here. And then over here, same thing, solve these and then graph them. You should be able to graph these. And you can use Desmos to check your work. All right, we will obviously get help on Zoom. See you then. Have a great day.